All right, hello Algebra 2 students, this is Mr. Bear, and I am bringing you what is mislabeled on here as 3.4, but it is actually 10.2 guided notes, okay? So that is still correct. All right, so this lesson, I'm gonna keep it short and sweet. Sorry I'm missing you all today to be able to do this, but I just wanna make sure that you understand how to work with composition functions, okay? So in general, when you're doing a composition, what you're doing is you're going to replace the inside function variable, or sorry, the outside function variables with the inside functions. Okay, so let me just show you what that means. So if I'm looking at example A, first I look at what my outside function is, which is f. Okay, so that means I'm going to have 2 times something plus 5. But that something is going to depend on what g of 3 is. Okay, so g of 3 means I take my g of x function and replace the x in that function with 3. 4 times 3 is 12. Take away 1, we get 11. So that 11 is what I'm going to put into my f function. 2 times 11 is 22, plus 5 more gives me 27. So that's going to be my answer to this. Okay. If I ask you to do g of f of 2, well, this time my outside function is g of x, so I'm going to take that g of x and write 4 times something minus 1. To figure out what that is, I'm going to figure out what f of 2 is. So f of 2 is going to be my f of x function, 2 times 2 plus 5. That gives me 4 plus 5, which is 9. And that 9 is what's going to go into my function here. 4 times 9 is 36. Take away 1, you get 35. Okay? Now, what if I don't have an input to put in, so the x isn't a number? Well, what that means is we take our g of x function. In this case, it's 4 times something minus 1. And we're going to replace that outside function with our f of x function, f of x being 2x plus 5. So that's going to go inside. But I don't know what x is, so I'm going to just simplify this equation. All right, so we distribute here. We get 8x plus 20, and then bring down your minus 1. So your function is 8x plus 19. Okay. If I asked you to do f of g of x, f is the outside function, so we're going to take our outside function of f of x, which is 2x plus 5. And I'm going to replace that something with my g of x function. G of x being 4x minus 1. Then we're going to distribute here. We get 8x minus 2 plus 5. Combine the like terms, you get 8x plus 3. All right, and that is how you're going to handle doing those. All right, so now let's try another one here, okay? So this one, I give you two different functions, and we want to find g of f of x. So notice the outside function is g, so we're going to have 3 times something plus 2. All right, then what we do is we replace that something with our f of x function, which in this case is 2x squared minus 3x. And then we just distribute, so we get 6x squared minus 9x, and then plus 2. And at this step, I'd combine like terms, but I don't have any like terms, so that's all I'm going to have there. Oops. Okay, back side of our notes. Let's see what happens if I do a composition with these functions. Okay, something special is going to happen with these ones, which we'll talk about more in a later lesson. But to do the compositions, okay, look at your outside. Outside is f of x. So we're going to take our f of x, 7 times something squared plus 5. I think I'm writing this a little bit too big, because we're going to need some room here. So let me go ahead and do that again. So we have 7 times something squared plus 5. We're going to replace that something with g of x, which is this, like so. And then we're going to simplify. Okay, so the first thing I notice here is I have a square root that's being squared. So those will cancel out, and I have 7 times x minus 5 over 7 plus 5. Next thing you might notice is, oh, those 7's cancel out, and we get x minus 5 plus 5. Lastly, you might notice, oh, the minus 5 and the plus 5 cancel out, so my final answer is x. Okay? All right, let's try the next one. This time we're going to do g of f of x. So my g is the outside function. Let me erase some of this here. G is the outside function this time, and so that means I'm going to take the square root of something minus 5 over 7. And that something is going to be my f of x function, so 7x squared plus 5. All right, so then we just simplify. So on top I notice plus 5 minus 5, those cancel out, leaving me with 7x squared over 7. Next thing you might notice is the 7's cancel out, so that gives me square root of x squared. Last thing you might notice is x squared cancels with, square root cancels with the squared, giving me a final answer of just x. When this happens, when both compositions give you x as your answer, what we would say is that these things are inverses. Now you might be thinking, what does that mean? We'll talk about this after spring break, but just know right now that that means that these are inverses because we ended up with x in each situation, okay? All right, so now that we've done that, let's try doing these with tables of values, okay? So when I look at this table here, I notice that the top table is my f of x function, my middle table is my g of x function, and we're asked to find g of f of x, okay? All right, so the way we do this is we start with our inside function. All right, so my inside function here is f of x. My input is 1, so I'm going to go up to my f table and look at my input of 1. When my input is 1, I get an output of 2. So now I need to find that 2 as the input for g. So that means I go here, and its output is -3. So that's what goes here. Okay, let's try that again. So now my input is 2, so I'm going to go up to my top table, look where f has an input of 2, that has a -1. So then I find that -1 is the input for g. Ooh, I don't know what I just did there, but let's fix that. There we go. And we have an output now of 0. So when x is 2, g of f of 2 is going to be 0. Okay, and we're just going to keep on doing this, all right? So next one, we have an input of 3, so I go up to my f table, look where the input is 3, I get an output of 5. So then that output of 5, I now go to the g table and look for that as the input, and that output is 1. Okay, and then I just keep on going. So g of f of 4, so f of 4 is 7. That 7 gives me on the g table an output of 5, so that goes here. For the next one, when my input is 5, I go to the f table, find my 5, output is 19, follow that to the g table, the output for that 19 is 12. So then the last one, 6, gives me an output of 4, find that on the G, and its output is also 4. So that's how you're going to handle that, okay? All right, last one that we'll do is what if they are graphed? If I want f of g of 1, first I find g of 1. So notice that the first table is f of x and the second, graph is f of x and the second graph is g of x. So when I want g of 1, I go to the g graph, look up where x is 1, the output value is 2, okay? So then that 2, I find f of 2. So now I go to the f graph, look where x is 2, and since its output is on the origin, I get, or not origin, but at 0, I get 0. So the answer to f of g of 1 is 0. All right, let's try another one. Okay, so f of 1, do that first. F of 1, I go to my f graph, look where x is 1, and on the graph I have an output of -2. So then I find g of -2, so I go to the g graph, look where x is -2, its output is -1. So then the answer to g of f of 1 is -1. Okay, last one here that I'll do, f of 3. So first I figure out the inside f of 3. So I go to my f table, look where x is 3, output is -1. Oops. Then I use that output to be my input for the also f function. So f of -1 gives me an output of 2. So then the answer to this problem is 2. All right, so now you're going to do your skill check, and when you're done with that, you will turn that in, and you will not have a delta math on this, but instead you will work on your packet that you were given that has the 10.1 and 10.2 information. We are going to have a short quiz over 10.1 and 10.2, but don't worry, we will review again this concept before you take that. All right, that's all I have.